Welcome. Today we're going to learn how to draw perfect shapes. I'm not talking about guesswork or tracing, but with the pure, satisfying precision of a real architect. We're turning a blank page into a blueprint. So think of this as a builder's journey. We're going to start with just a single line, and believe me, by the end of this, you'll have the skills to construct complex, beautiful shapes all with your own hands. Here's our blueprint for today. First, we'll get to know our tools. And then we'll move on step by step, building our skills right from the ground up. Okay, first things first, let's open up the toolbox and look at the essential gear that's going to turn your piece of paper into a full-blown construction site for ideas.
A protractor, a ruler, and a set square. That's it. These 3 simple tools are literally everything you need for geometric precision. The Cambridge Lower Secondary curriculum points this out too. Mastering these is step 1 to building perfect shapes.
What's really powerful is how just a few precise actions with these tools can unlock the ability to draw almost anything you can imagine. So let's master those actions right now. Okay, the first skill is the most fundamental, drawing a line to an exact length. It might seem super simple, but this is the foundation for every single shape we're going to build today. Precision starts right here. Next up, angles. This is how we give our shapes some character, some real form. When you use a protractor, you're not just guessing, you're defining the exact turn and tilt of your lines, and that is absolutely essential for what's coming next. And this brings us to a really crucial skill, mastering the 90-degree angle. Using your set square to create these perfect perpendicular lines is the key to stable shapes with sharp, clean corners. It's basically the bedrock of any reliable design. So now that we've mastered our lines and angles, it is time for our first major construction project, the triangle. In the world of geometry, it's the strongest and most fundamental shape there is, which, if you think about it, is why you see it holding up everything from bridges to radio towers. Now, the curriculum gives us 2 powerful techniques for this. SAS, which stands for side angle side, and ASA for angle side angle. The real secret here is knowing which method to use based on the clues you have. And hey, don't make any mistake, these methods aren't just some neat tips or tricks. They are a core part of the official mathematics framework, a foundational skill for any aspiring designer or engineer. So take a look at this. By applying those SAS steps, you draw an 8-centimeter side, you measure that 55-degree angle precisely, and then you draw the 5-centimeter side, you create this perfect, unchangeable triangle. It's completely locked in. There's zero room for error. Okay, with our triangle foundation firmly in place, we can now start building upwards. We're raising the walls by constructing those familiar, everyday shapes of squares and rectangles. The process itself is simple, but it demands precision. You draw a baseline, then you use your set square to build a perfect perpendicular line at each end, kind of like framing a doorway. Measure the height and connect the dots. Every single step relies on that perfect right angle. And here is the result. I mean, look at that clean, sharp shape. Every corner is a perfect 90 degrees. The opposite sides are exactly parallel and precisely equal in length. That's not a guess, that's a construction. All right, now it's time for the final challenge. This is where we combine all of our skills, drawing lines, measuring angles, repeating steps with total precision, to create some more complex and really beautiful regular polygons. Now, here's the cool part. To build any regular polygon, whether it's a 5-sided pentagon or an 8-sided octagon, you only need 2 key pieces of information: how long the side is and the size of the internal angle. So by repeating a simple process 6 times, you draw a 6-centimeter side, you measure a 120-degree angle, then you draw the next 6-centimeter side, this incredibly complex and symmetrical shape just emerges from simple, repeatable rules. That is geometry in action. Fantastic work. Let's just take a moment to step back and recap this incredible journey we've just completed. I mean, think about it. You've progressed from drawing a single, simple line to having the skills to construct these intricate and precise geometric forms. You followed the exact path of a designer. Just 3. That's how many simple tools it takes to unlock the ability to draw almost any 2D shape in the universe with perfect mathematical precision. So what's the biggest takeaway here? It's that you've learned more than just how to draw, right? You've learned a whole system for creating order, structure, and precision right out of a blank page. And this just goes to show you, these aren't just some abstract exercises. These shapes are the fundamental building blocks of the world all around us, from patterns in nature to the objects we design and use every single day.
Look around you, at the buildings on your street, the bridges you cross, the patterns on the floor, the objects on your desk. Now that you're the architect, I promise you'll start seeing them absolutely everywhere.